Hey guys, tonight we're shooting Thor's helmet. This is a narrowband target, and we should be finishing this up tonight. My name's John Robinson, the Astrotard. This is Deep Sky. NGC 2359, Thor's helmet, is an emission nebula. It's about 30 light years across and about 20,000 light years away from us. Its central star, WR7, is about 1.4 times as massive as the Sun and some 200,000 times brighter. It's the type of star that's expected to go supernova in the near future. In fact, the reason that the nebula exists is because of that central star expelling its gas at such a rate that it's interfering with the nearby hydrogen region, creating the ionization and the emission nebula that we see in that region. It's located in the constellation Canis Major, and you can see it this time of year in the low southwest skies. I captured this in the Hubble palette, meaning that I used Astrotard and ZWO narrowband filters, hydrogen alpha, oxygen, and sulfur. Let me show you how I mixed it, and we'll look at the result. Hey guys, let me show you how I mixed this together. First thing I want to show you is the number of sessions that I used. In all, I had 121 subs and about 11 hours of data. I captured this over 6 different sessions: April, March, February, October last year, and April last year. Had a mix of 10-minute, 2-minute, 1-minute, and 5-minute exposures, and also using both Astrotard and ZWO filters. So it's again another Heinz 57 kind of result. About 121 subs, 11 hours of data is what I've got. The challenge that I had, given that I had 6 different sessions, each one of these sessions I changed the imaging train in between, which means really I had to use different calibration frames, especially the flats. So I had 6 different sets of flats for all of the filters that I used in here. So a lot of calibration frames in order to get all of this data to look good. Let's look at it from PixInsight. I used the script weighted batch preprocessing, which was overkill because I really didn't use the weighting at all. I could have just done the regular batch preprocessing. And the other thing was I did not do the integration. And again, the reason for that is I had to run this 6 different times, and so I did not want to integrate it 6 times. I waited until I had everything calibrated and registered. So all the script was doing was calibrating it, applying the flats, darts, and bias, and then doing a registration, aligning everything up to one master frame. Then when I was all done, let me show you kind of where that ended up looking here. Under Thor's helmet, you can see I have a light folder. I have February, March lights, April lights, October lights, even another folder full of older stuff. So again, 6 different folders, and in the end, what I ended up with was 126 calibrated subs. And then I registered everything in these folders S, O, and H. So I mixed all those different filters and all those different exposure lengths into these folders here. And then I used the image integration tool here to just integrate what the script had created for me. So for example, we're in the S folder here. I added the sulfur data here. I added the drizzle files here. And I was using the exposure time as the weight because I wanted the 10-minute exposures to have a heavier weighting in determining the average pixel value. So then I went ahead and ran this 3 times, once for sulfur, once for hydrogen, once for oxygen, to come up with the 3. So let's just kind of have a quick look and see what the sulfur one ended up looking like. And you can see from the rejection low, given that I had those 6 different sessions, you can see the slight rotation where the camera was slightly different aligned in those sessions, and so it recognized that and threw those out. And then here's what the integrated S looked like. And S is not, the the most rich in terms of data. But yeah, that's what it looked like. So let's look at the individual ones. Here's the H that I used. Let's actually rename that to H so we can see that. Close the integration. So here's the H that I used. Here's the oxygen. Both hydrogen and oxygen were pretty strong. And then again, you saw the sulfur. So here's the sulfur. Okay, now before I did any stretching at all on these, I just did a simple mix. So I used pixel math for that, and I just did a S for red, H for green, O for blue, the Hubble palette. Mixed that together, and it looked like this. And it's quite blue, which is normal. Then I did an ABE on this to get rid of, and it's blue because if you mix it before you stretch it, that's what you get. But after I did an ABE, it sort of neutralized and equaled out. And now it's starting to look like that traditional Thor's helmet in narrowband. And that was my starting point. From this starting point, let me show you what I did to the file. I did an SCNR on it to clean up the some of the green. I did a histogram to push the white up a little bit. I did an AC DNR with a mask on it to get rid of some of the noise on the background. I changed the name to be SHO. I did a crop on it. You can see why, because of the stuff on the top here. I wanted to get rid of that, so I cropped it out there. Then I did another histogram on it, so I inverted it, so meaning that I was protecting the stars and nebula, and I turned down the sky, and then turned it back up, and then turned up the brightness on the nebula. And I should mention that I did that with the SHO Loom file, which included the stars. And then I did it using the nebula only mask. I applied a sharpness and a local histogram and a curve transformation. Let me show you what I mean by the difference there. So we had here's my nebula that I used just for masking the nebula, and here's the nebula and the stars together. So those are the two different masks that I was using. And then from that point, I did an automatic background extraction. Let me kind of show you from there what it looks like on the final one here. So after the automatic background extraction, I renamed it to be final. And I did another AC DNR on it. And then I had some asteroids that I needed to clean up, so I did a clone stamp. And then I pushed the colors just a bit, both in the S and the C on that. And here's what I ended up with. So this is my final result, and I kind of like it. It's 11 hours of data. It's it's okay. I guess I say I kind of like it. What do you guys think? Let me know in the comments if you have any feedback for me or any questions on the technique that I used. And otherwise, thanks for watching. Clear skies to you, and we'll see you next week.